Hello, in this video we'll discuss the electronic or digital voltmeter. The voltmeter is composed from the parts shown in this diagram. First, the voltage that is unknown or we want to measure will be applied at this point. Then it will give a signal to the voltage modifier. The voltage modifier will modify the voltage that we want to measure and pass a signal to the comparator circuit. The comparator circuit receives two signals. The first one is from the voltage modifier and the second one is from the oscillator. Then it will pass a number of pulses to the computer system, and that number is directly proportional to the voltage that we want to measure. The computer system will analyze that number and give the result by the use of LED viewer. The first part of the electronic voltmeter is the voltage modifier. The voltage modifier is composed mainly from two things. The first one is the selector disc, and the second one is multiple branches. Their ends all connected in this point, and each one contains a resistor. The value of that resistance is directly proportional to the voltage that we want to measure. After these branches, a signal will pass to the comparator circuit. The reason behind using voltage modifier is to widen the range of voltages that we can measure with the same voltmeter. Let's suppose that we apply the potential that is unknown in this point. Then, by the use of the selector disc and selection of a proper branch, a current will rise in that branch, and that branch contains a resistor. Its value is R ohms. Then the value of that current in that branch is equal to the potential difference between these 2 points divided by the value of the resistor. So after simplification we will get V up after modification is equal to V up minus the current multiplied by the value of the resistor. Now the second part of the electronic voltmeter is the comparator circuit. As you see in this figure, the comparator circuit is composed from NPN transistor, which will act like a switch. The daily used electronic voltmeter contain operational amplifiers, but I used NPN transistor to show variety in the design. This circuit will receive two signals. The first one is from the voltage modifier, and the second one is from the oscillator, and it will give one signal to the computer system. The voltage after modification will be applied here, and the current will rise in this branch, passing through this time-dependent switch. And that switch will close and open automatically depending on a time interval which has been set in it previously. When it's closed, a potential difference will rise between these 2 points, and the current will pass in this branch and in this branch. And when it's open, there will be no potential difference, leading to that this circuit and this circuit binding in series. This circuit is called the capacitor circuit, which contains a capacitor with a known capacitance and a small value resistor, and both, as you see, are bound in series. The collector circuit is composed from a unijunctional diode. The negative terminal is bound to this point, and the positive one is bound to this point. The function of the diode is to prevent backflow of current in this direction when the transistor is not working. After this point, the current in the collector circuit will be summed with the current from the oscillator. After passing through the transistor, the current of the emitter is summed to the current from the oscillator. After this point, the current from the oscillator will pass in this branch to the computer system, leaving the current of the emitter in the emitter circuit alone. The current of the emitter circuit will pass through this large value resistor. And as you see in this figure, there is no any power source in the collector circuit, so collector current is equal to 0. And from Kirchhoff current law, we conclude that emitter current will be equal to base current. And that means when emitter current passing through this large resistor, then the impedance exerted by this large resistor is mainly on the base current. Now let's see what happens when the automatic switch is closed. When the switch is closed, a current will pass in this line. So a potential difference will rise between these 2 points. And a current will pass in this circuit and in this circuit. As the current passing through capacitor circuit, the capacitor will begin to charge. So the potential difference between these 2 points will be equal to the voltage drop in this resistor and the potential difference between capacitor plates. As we know that current is equal to the change in the charge between the capacitor plates for the change of time multiplied by R plus Vc. And as we know that the charge is equal to the capacitance of the capacitor multiplied by the potential difference between the 2 plates of the capacitor. After simplification of the equation, we get dVc divided by V minus Vc, which is equal to dt divided by Cr. And Cr here is gamma, which is the time constant of charging. So by taking the integration of the 2 sides, we get minus ln V minus Vc, which is equal to T divided by gamma plus K. And K is the constant of integration. Its value can be known from the initial conditions. When time is equal to 0, the potential difference between capacitor plates is equal to 0. So K will be equal to minus ln V. So by putting this value in this equation, we get ln V divided by V minus Vc, which is equal to T divided by gamma. And from that equation, we conclude 2 things. The first one, after simplification in this manner, is that the potential difference between capacitor plates is directly related to the voltage that we want to measure, when both the time of charging and time constant of charging are constant. And the second one, after the simplification in this manner, is that the time of charging is directly proportional to the time constant of charging. And for that reason, we used a small resistor in the capacitor circuit so that to decrease the time constant of charging, and that will lead to a smaller time of charging when both the voltage that we want to measure and the potential difference between capacitor plates are constants. Now let's see what happens when the switch is opened. When the automatic switch is opened, there will be no current in this line. So, the capacitor circuit and base circuit will act like a single circuit. And as we know previously that collector current is equal to 0. So, the current in capacitor circuit and the current in the base circuit together with the current in the emitter circuit are all equal to each other. The other thing that we conclude is that the resistance in the whole circuit is equal to the sum of the small resistance and the large resistance. From Kirchhoff's voltage law, the potential difference between capacitor plates is equal to the voltage drop in this resistance and in this resistance, which is equal to minus IC multiplied by R total, which is the sum of the small resistance and large resistance. By the simplification of the equation, we get dVc divided by Vc, which is equal to minus dt divided by gamma. And gamma here is equal to Cr, which is the time constant of discharging. By taking the integration of the two sides, we get ln Vc, which is equal to minus t divided by gamma plus k. And k is the constant of integration. Its value can be known from the initial condition. When the time is equal to 0, the potential difference between the capacitor plates is equal to the initial potential difference between them. So, K is equal to ln Vc initial. By putting this value in this equation, we get ln Vc divided by Vc initial will be equal to minus t divided by gamma. So, ln Vc divided by Vc initial will be equal to minus t divided by gamma. And in our experiment, Vc is equal to the minimum voltage required to make the transistor work. So, it's a constant value. T divided by gamma will be equal to minus ln Vc divided by Vc initial. So, T divided by gamma will be equal to ln Vc initial divided by Vc. So, T will be equal to gamma multiplied by ln Vc initial divided by Vc. And from that equation, we conclude two things. The time of discharging is directly related to ln Vc initial, which is directly related to the voltage that we want to measure. And that's the basic principle of working of the voltmeter. The second thing is that the time of discharging is directly related to gamma, which is the time constant of discharging. And that's explain why we used a large resistor in the emitter circuit, so that it will result in larger time constant of discharging, and that will result in larger time of discharging, and that will lead to a greater sensitivity of the voltmeter. The third part of electronic voltmeter is the pulse generator. There is a large number of pulse generators, but I use this type. This type is composed from 4 resistances, bound in that way, 2 capacitors, and 2 similar NPN transistors. The positive end of the voltage that operated will be applied here, and the pulses can be taken either from this point or from this point. The principle of working is as simple as that. When one transistor is working, the other is not. The frequency of oscillations is inversely related to the R multiplied by C.